Whenever we are going to find the angle between a plane and a line, there is only few steps that you have to follow. Okay, so let me draw a plane for you first of all, and let's say if the line, okay, let's say if the line is parallel to the given plane, the angle between the plane and the line is 0 degree. Clear? So we know if this is the line L, and if this is the angle, the plane phi, if L is parallel to pi, the angle between the plane and the line theta can be given as 0 degrees. Okay, so this is not a problem. Okay, what we are focusing here is the angle between the plane and a line if the line passes through the given plane. Okay, if the line passes through the given plane at a single point. Okay, so this is the point it is passing through, and let's say this is phi, and let's say this is line L. How we can do this is we normally know that a line is given in a vector equation, or we can find the vector equation, no worries. So let's say it is given as r equals to a plus lambda b. Okay, and let's say pi is given as ax plus by plus cz is equals to b. Okay, so let's say this is the Cartesian equation of the plane phi. So by using this, I can find the normal vector. Yeah, I can find the normal vector. Okay, so let's say this is the normal vector, and let me draw it. So this is the normal vector. So we know this is 90 degrees. Okay, so n can be given as a comma b comma c. Okay, so this will be the normal vector n. Okay, so how can we find the angle between the line and the plane? Okay, normally what we want to find is this angle. Okay, this angle. This angle is what we want to find. Okay, so we know the direction vector of line L can be given as b. Okay, and if I bring this normal vector, okay, if I bring this normal vector to like here, okay, if I bring it like here, okay, since we don't care about the point of the normal vector, we just care about the direction of the normal vector here also. So this will create a right angle triangle. Okay, let me draw that right angle triangle for you. So this is the right angle triangle that is created by connecting the line and the direction vector. Okay, so this is the 90 degrees mark. Okay, so if you look at this right angle triangle, okay, if you look at this right angle triangle, okay, if you look at this right angle triangle, the funny thing about this is that the angle between the direction vector and the normal vector we can find. Okay, so let's say this is the normal vector, and let's say this is the direction vector. This angle actually we can find. Okay, let's say this is theta. Okay, so we can actually find theta. How? Cos theta will be equals to the dot product of b and n over modulus of b and modulus of n. Okay, so if you have any doubts, I will link the dot product in the link. I will leave the explanation of dot product in the description. Just check it out. So we can find cos theta. We know this is 90 degrees. Well, then this will also be 90 degree theta. Why? This is the vertically opposite angle, and this guy will be equals to 90 minus theta, which we want to find, the alpha. That's what we want to find. So since we know cos theta, we can find theta. Theta can be given as cos inverse the scalar product of b and n over modulus of b into modulus of n. Okay, so alpha will be equals to, okay, alpha will be equals to 90 minus theta. Okay, so alpha will be equals to 90 minus theta. So since we know theta, we can substitute here and find the angle alpha. Okay, we can find the angle alpha. If you know, if sometimes theta can be acute angles, sometimes theta can be obtuse angles, right? Because that's what scalar product is all about. Because we know if two vectors are going like this, okay, if two vectors are going like this, we can say the angle between these two vectors is 90 less than 90 degrees. If it is greater than 90 degrees, okay, we can say it is obtuse angle. So theta is greater than 90 degrees, but obviously less than 180 degrees. So these are the two possible scenarios. If you find that theta is equals to theta is less than 90 degrees, you can use the equation alpha is equals to 90 minus theta to find alpha. Okay, if the angle theta is greater than 90 degrees, you will use alpha is equals to theta minus 90. Okay, how do we come up with this? Well, it's actually simple. Okay, it's actually simple. Let me draw it for you. Okay, so let's say this is the plane. Okay, let's say this is the plane. Okay, and this is the line that is passing through the plane. Okay, and the direction vector. Okay, the direction vector is given as in this direction. The direction vector is given in this direction. Okay, and we know the normal is normally given in upward direction. It doesn't always have to be the upward direction, but it can be in the upward direction. So now, if you see this, the angle we will be finding is this angle, theta. Okay, so we will be finding the angle theta here. Since this is the direction vector of the line and this is the normal vector, this is the angle that we will find. Okay, so this will be equals to 180 minus theta. Okay, and if I connect this right angle triangle, this will be 90 degrees. So we know 90 plus 180 minus theta plus alpha, because this is what we want to find. Plus alpha will be equals to 180. Okay, so alpha will be equals to theta minus 90 degrees. Okay, so if the angle you find between the normal and the direction vector is obtuse, well then you have to use the equation alpha is equals to theta minus 90. Okay, or else if the theta is less than 90 degrees, you can use the equation alpha is equals to 90 minus theta. Okay, so let's do a simple question. First of all, let's say a line is given by the equation r equals to 1 2 3 plus lambda 4 5 6. Okay, so from this line equation we should be able to find out the direction vector. The direction vector can be given as b equals to 4 comma 5 comma 6. Okay, and then what we have to do? Well, then we have to check for the pi equation. So let's say pi is given as 22x minus 5y minus 8z equals to some random value 24. Okay, so now we know the normal vector is equals to 22 minus 5 and minus 8. Okay, so first of all what we have to do is we have to check whether the line and the plane are parallel to each other. So for that we have to check b dot n. So b dot n, if b dot n is equals to 0, we can say L is parallel to pi. Yeah, that's what we learned. So b dot n will be equals to 4 into 22 is equals to 88. 5 into minus 5 will be equals to 25, and minus 8 into minus 6 is equals to minus 48. So this is definitely not equals to 0, which means line L is not parallel to the given plane pi. Okay, so now we can find the angle, right? But since we have found out the scalar product, b dot n can be given as 40 and 40 minus 25, 15. Yeah, so this is the b dot n value. Okay, now what we have to find the modulus of b. So modulus of b can be given as square root of 16 plus 25 plus 36. Okay, 4 square plus 5 square plus 6 square, because that is the coordinates of b. So this will be equals to square root of 41 and 41 plus 36, 77. And we have to find also the modulus of n. So modulus of n will be equals to square root of 22 square will be equals to 484, right? 2 into 22, 40, 484 plus 25 and plus 64. So this will be equals to 25 plus 64 is equals to 89. So 564, 573. Square root of 573. Okay. So the angle between these two vectors will be equals to cos theta. Let's say the angle between the b and n is theta. So cos theta will be equals to 15 over square root of 77 into square root of 573. Okay, so theta will be equals to cos inverse 15 over square root of 77 into square root of 573. Okay, but we know what we have found out is the angle between b and n, and since the ratio is a positive number, we can say this is the normal vector, and we can say this is the direction vector. This is the angle theta. Okay, so if you complete the right angle triangle, this will be 90 degrees. So since this is equals to theta, we can say this angle is equals to 90 minus theta, or we can say that is alpha, which is equals to 90 minus theta. So alpha is equals to 90 minus theta. you can use your calculator to find this value and substitute it to find the alpha value. Okay, so first of all, check whether the line is parallel to the plane. Okay, so that for that you have to find the scalar product of b and n, the direction vector and the normal vector of plane, direction vector of line and the normal vector of plane. Then what you have to do, if it is not equals to 0, we can go to the other steps and find the angle. Okay, now let's do another question. In this question, we have been given the plane phi and the line L. So but the thing is, it is not in the Cartesian equation, so we have to find the Cartesian equation. Okay, so we have two direction vectors 1 2 3 and 4 5 6, so we can actually find normal vector n. Normal vector n will be, so let's say b is equals to 1 2 3. Okay, and p is equals to 4 5 6. Okay, so the normal vector n, let's say phi, is perpendicular to n, which implies normal vector n will be equals to the cross product of b and c. The order doesn't matter here. So let's find that out. So this is I, and then j, then k. Since we have written down b here, let's write down 1 2 3 first, then c, so 4 5 6. Okay, so the normal vector n will be equals to I into 2 into 6 12 minus 15 minus j into 1 into 6 6 minus 12 plus k into k 1 into 5 5 minus 8. So we will get minus 3i plus 6j and minus 3k. Okay, so what I can do is I can rewrite this as minus 3 into, okay, I minus 2j plus k. Okay, in the direction vector we don't care about the, I mean the normal vector, we don't care about the magnitude. Actually here we only need the direction of the normal vector, so we will use 1 2 and 1. Okay, so we know r dot n can be given as a dot n. So r is in this case x, y and z, because that's what we are trying to find, and n is given as 1 minus 2 and 1. And a you can use 4 5 6. Why? We have been given the position vector of a point on the plane as 4 5 6, so it will be 4 5 and 6. N will be 1 minus 2 and 1, so x minus 2y plus z can be given as 4 into 1 4 minus 10 plus 6. Okay, so the equation is coincidentally x minus 2y plus z is equal to 0. So this is the plane, the Cartesian equation of the plane phi, which can be given as phi can be given as x minus 2y plus z is equals to 0. This is the Cartesian equation. Since we have the Cartesian equation, we can go and find the direction, whether the line is parallel to the given plane or not. Okay, for that we have to find the whether the b dot n is equals to 0. Well, in this case not b, let's say b is equals to 3 minus 2 4. Okay, 3 minus 2 and 4. So we have to find d dot n. D dot n will be equals to 1 into 3 3 minus 2 into minus 2 plus 4 plus 4. Okay, so it will be equals to 11, which is not equals to 0, which means, okay, which means line L is not parallel to the given plane phi. So now we have to find the magnitude of b. Okay, magnitude of b can be given as the square root of 3 square is 9 minus 2 square is 4 and 4 square is 16, so 29. We have square root of 29, and we can find the magnitude of n also. That will be given as 1 plus 4 plus 1 1 plus 4 plus 1, so that will be square root of 6. So the angle between these two vectors, okay, these two vectors, let me draw it for you. So this is also positive, right? Yeah, this is also positive. So the angle between these two vectors, we complete the right angle triangle also, because in the future it will be useful. So this is line L and this is plane phi, and this is the angle which we are trying to find. This is 90 degrees. This is the normal vector. This is the direction vector d. Okay, so this is the angle that we are trying to find. So cos theta can be given as 11 over square root of 29 into square root of 6. So theta will be equals to cos inverse 11 over square root of here 12, here 54, so 174, and alpha will be equals to 90 minus cos inverse 11 over square root of 174. Okay, so this is what we have to find. Okay, so this is what we have to find. Thanks for watching the 30-minute video in our lecture series. If you found this explanation of the angle between a plane and a line helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.